Well, we are officially on day 3 of the coronavirus quarantine, NTI, toilet paper shortage, spaghetti noodles missing, whatever day it is thing. Um, so far, I appreciate that several of you have asked me questions, participated in Zoom meetings. I'm not criticizing those of you that did not participate in these Zoom meetings. I realize that since many of us, or since we're out of school right now, several of you have jobs, and those jobs have asked you to come in and work more hours. I get that. So I'm not criticizing you for not participating in the Zoom meetings. There'll be plenty other opportunities, and I hope you'll take advantage and participate when you can. I would like to set up another Zoom meeting, possibly for this Friday. So those of you that watch this video are going to be aware that there is a Zoom meeting going to be set up for Friday. So start sending me times that are going to work for you, and I'll set something up tomorrow and send out the link to let you guys know when we'll have the next Zoom meeting. Like I told you guys before all this happened, I wanted to try to meet with you at least twice a week, face to face, as best we can. I just miss seeing you guys too. I just want to make sure that I am ensuring that you are getting the proper instruction that you need to get, especially since this is a dual credit class. It's a lot more stringent now, and it's a lot more responsibility put on you guys to be successful. I'll do everything I can, though, to make sure that that happens for you. We are talking about areas under the standard normal curve. When you guys go to the website, there will be 2 documents here. You'll have these notes. There's also going to be another PDF called the Z table, and we're going to use the Z table in these notes, so you'll kind of know how to use that. Print the Z table, save it on your computer. We're going to be using the Z table a lot from here on, and it is important to understand how to use it. The area under a normal curve. So let's just talk about some of the basic properties of a normal curve. The total area under any normal curve is always going to add up to 1. So that makes perfect sense since we're talking about probabilities. Probabilities all add up to 1. The standard normal curve extends indefinitely to both the left and the right. It never actually touches what we would consider to be the x-axis. That's not to say that it is an infinitely large graph, but there's just a finite amount of area that we're particularly interested in, specifically -3 to +3 standard deviations from the mean. Almost all the, and that leads me to property 4 there, almost all the area under the standard normal curve lies between -3 and +3. And that's when we talk about the z values. Remember, we use the z value to standardize any variable. And then also property 3, which I skipped over. The standard normal curve is symmetric about the mean, which is always going to be 0. So mean is 0, standard deviation is 1. These are things that we should be familiar with. And I will sketch on here real quick just what we're talking about with the standard normal curve. It is the bell-shaped curve that looks like this. Here is my axis. The graph actually never touches that axis. We have our mean is at 0, and then we have 3 standard deviations to the right and 3 standard deviations to the left. In between -3 and +3 standard deviations, that encompasses roughly, actually slightly more than 99% of all of the data that we would be evaluating. And we'll talk about that, I believe, in the next set of notes when we talk about a special rule that deals with the specific standard deviations. So the standard normal table, or the Z table, again, like I said, that's on the website. You will use that. I'm going to be flipping back and forth on our notes and the Z table here. I did say that the Z table is provided at the end of these notes. I did not add it into these notes. I provided it as a separate document. The Z table, so let me just show you what it looks like before we go into this example. Here is the standard normal distribution table, or the Z table. You can see that we have Z scores on the left-hand column. These are all negative values. So the second page is going to be all the positive values. Now these z values, remember, that indicates how many standard deviations a particular data point lies to either the left or the right of the mean. So page 1 is all the data points that would lie to the left of the mean, has a negative z-score. Page 2 is all the data points that would lie to the right of the mean, which would mean it would have a positive z-score. Don't get overwhelmed just yet. We will talk about how to use this. So let's look at an example of how to use that. It says determine the area under the standard normal curve that lies to the left of 1.23. So what that's asking us is, what is the area under this curve to the left of a z-score of 1.23? That's where the table comes in handy to compute these. So if you go to the table and we're looking at a positive 1.23, so we have positive 1 here on the z value, and then we go, let's see, this table, sorry, 1.2, and then we go over until we get to 0 or 0.03. This is the area under the curve at 1.23. So the left-hand column is the whole number part and the tenths place of the decimal, and then the vertical columns represent the hundredths place. So 1.23 lies at the intersection of 1.2 and 0.03. So we get a value of 0.89065. We convert that 0.89065, which is roughly 89.07% of the data lies within that particular curve. As far as the area goes, we do just want to express it as the 0.89065. With example 2, it asks for the area that lies under the normal curve to the right of 0.78. So the z-table tells you all the values that lie to the left of the z-score. So to find the area that lies to the right of a given z-score, you would use the table, which would generate the area to the left, and you would just take that value and subtract it from 1. So because the total area is 1. So when I look this up, when I look up a z-score of 0.76, what I'm going to find in the table is the area to the left of 0.76. So let's go to our table and find that. It is a positive value, so 0.76. Right here we have 0.7. We're going across to 0.06. It's 0.77637. So this is 0.77637. But keep in mind, that's the area that lies to the left of that value. We want what's lying to the right of the value. So we just do 1 minus 0.77637. And let me type that in. We get 0.22363. So the area that lies to the right of 0.76 is 0.22363. What about an area that lies between two z-scores? So we want to take our table here and we want to find the value that lies to the left of negative 0.68. So that's going to give me this region here in orange. Then I'm going to have the area that lies to the left of 1.82. That's going to give me this area here in pink. The reason I drew this on here is because what you're going to notice is if I take the area in pink and subtract the area that is in orange, I'm going to be left with this area that's here in green. I apologize for all the colors if that's confusing to you. Maybe mathematically it will make more sense when we do this. So let's first look at negative 0.68. So we'll go to our z-table. And in this case, we're looking at a negative value. So we'll go to page 1. And it's negative 0.68. So let me see, where's column 8? Right down there. Negative 0.6. out to 8 is 0.24825. So we have 0.24825. That's the area that we shaded earlier in orange. Now we need to find the area that lies to the left of 1.82. So that's going to be on the second page. 1.82 is going to be 0.96562. And that's the area that we shaded in pink. So to find the area in green, which is the area to the left of z-score of 1.82, but not including the area to the left of negative 0.68, we just take 0.96562 minus 0.24825, and we will type that in. And we get a total area of 0.71737. So the area that lies between those two given z-scores is 0.71737. Finding a z-score for a specified area. So in this case, now we're going to work from the inside of the table out. We know the area. We need to find the z-score. And we're going to see that here with example 4. Determine the z-score having an area of 0.04 to its left under the standard normal curve. Well, an area of 0.04 is going to lie to the left of the mean. So let me see if I can draw a good line here. So here's our mean. So if it lies to the left of the mean, it means it has a negative z-score. So that kind of helps us narrow things down. So let's go to our z-table on the negative side of things, so page 1, and we're going to look through the values in the middle of the screen, everything in here, and we're going to find where we have a 0.04? Yes, 0.04. So scanning the values, somewhere right in between these two values will be a z-score of 0.0, or a area of 0.04. So that corresponds to negative 1.7, either 0.05 or 0.06. You can split the difference and say it's negative 1.755, or we could just say it's a negative 0.175. Close enough is going to be fine in this case. So we have C equals negative 1.75. That's what we're going to go with. And that's just traditionally how you're going to do that. If you have a z-score or an area that corresponds exactly, then obviously you want to use that value. If you have a value that falls between two given z-scores, take the average, and that'll give you the more appropriate approximation. The z-alpha notation. So the z-alpha notation is something that's used quite frequently. In this case, what we're talking about, you can see the definition. The symbol z sub alpha is used to denote a z-score that has an area of alpha to its right under the standard normal curve. So that's just telling us then that we're looking for a z-score that has an area of, in the case of part A on example 6, its area is 0.025 to the right of whatever that particular z-score is. So again, this is one of those cases. Remember, the z-table shows everything to the left of a z-score. So if we just take 1 minus 0.025, we should get 0.975. Is that right? I think so. Check my math. Yeah, 0.975. So we're looking on the table to find the z-score that has an area of 0.975. That's going to be on the positive side of the z-table because the area is greater than 1/2. So we'll go down here to the positive side is 0.9725. So scanning the table, or 0.975 rather, we get, oh, right there, perfect. We do have a value that is exactly 0.975. It's going to be 1.96. So we can see that 1.96 is an area of 0.975. So the corresponding Z value here, I forgot already. Sorry. 1.96. Okay. So Z sub 0.025 is equal to a Z score of 1.96. Then on part B, we're looking for Z sub 0.05. So we have 1 minus 0.05, which is going to be equal to 0.95. And we go back to our table, and we're looking for 0.95 in the middle values of the table here. So 0.95 is going to be somewhere between these two values. So that's going to be 1.6, and then somewhere between 1.64 and 1.65. So we'll say 1.645. Whoops. There we go. Z equals 1.645. Okay, so this is just simply a matter of learning how to use this table. That's all this set of notes really corresponds to. For example 7, it says find the two Z-scores that divide the area under the standard normal curve into a middle 0.95 area and two outside 0.025 areas. So if I find the Z-score that corresponds to this line right here, it gives me everything to the left, which would be 0.025. So let's go and compute that Z-score first from the Z table. So we're looking for 0.025. That will be in the negative Z values because it's to the left of the mean. And we're looking for 0.025. 0.025. Right there it is. We found it exactly. It's at negative 1.96. Okay, so we have negative 1.96. And then we want to find the one that has the area to the right that is also 0.025. We're going to use the table, but I'll talk to you about this here in a second, about the symmetry of this table. So the area to the left of this is going to be 1 minus 0.025. And we already found that in a previous example here on part A of example 6, which is a Z-score of positive 1.96. These values are exactly the same. One is the opposite of the other. They both have equal areas to the left and to the right. It's because of the symmetry of this graph. Remember, it's symmetric about the mean. So everything to the left is a mirror image of everything to the right. So if I have the same area to the left of some given value and I have the same area to the right of some given value, they will have the same Z-score, just opposite sign. So we have a negative 1.96 and a positive 1.96. That is it. These notes are pretty straightforward, I hope. It's just a matter of using the table. So the table will be provided on the website. As soon as this video is done processing, I'll upload everything. You guys will be good to go. Ask questions. Do not think twice about asking me questions. Send me a message anytime. If I am not busy, I will answer it immediately. If I'm tied up and I can't answer you right away, I'll try to let you know that. Otherwise, just be patient, but you will get an answer. I hope you guys are doing great, and I will be talking to you hopefully tomorrow, or Friday rather. So please be thinking about Friday. Let me know what times work for you, and I will talk to you then.